My name is Julian Lucas. I'm a bioinformatics systems analyst at UC Santa Cruz. I'm just going to quickly walk you through the data we have available for HPRC. So HPRC is open access, which means that we describe our data in AnVIL and GitHub as soon as it's produced in QC and we're comfortable that there aren't any errors or mistakes in it. It's free and available in AnVIL and S3. One thing to note is that the S3 bucket does not charge egress fees. So if you need to download data to your local, that's a good approach. But what we're going to show you today, hopefully, is that manipulating the data and using the data tables in AnVIL is very convenient. Data and assemblies are and eventually pangenomes are also uploaded to INSDCs. So we have uploaded our data to SRA, which is also mirrored to DDBJ and ENA. And then we're also uploading our assemblies to GenBank. And eventually the pangenomes will be uploaded there as well. So we're in the middle of a 5-year project. Currently, year one's data is released. Year two data and assemblies are coming soon, hopefully in the next few weeks. And that's going to be adding to our first 30 samples and putting out another 50 or so samples. So it's going to be a big release. In terms of data from year one, we have 30 samples included in the HPRC data production. And so that means that each one of those samples has Hi-Fi, Hi-C, Oxford Nanopore, child Illumina data in most cases, parental Illumina data, and bio-nano data. And some of those samples have strand-seq. So it's a very rich data set. To the data that we've included in the sequencing data production, there's actually additional samples which we've sort of scavenged for in other consortia. And so what that meant was that from the 30 samples, we were able to make 47 assemblies, which is 94 haplotypes. Those have also been released. Of those 94 haplotypes, we left a few out for QC, and then we added CMH13 and CHM13 and GRCH38 in order to create 5 different pangenome structures. So just really briefly, I wanted to show you kind of how nice this data is. For the Hi-Fi data, we have really high coverage. You can see it's all over 30x. It's really closer to 40x mean coverage. And then in terms of median read length, it's really nice and long as well. And so we've got a average median read length in the Hi-Fi from year one of about 20 kb. ONT is really impressive as well. We have average around 30 coverage, but really importantly, over 100 kb coverage is around 10x on average. So really nice high coverage. So with that, I'm going to break into the dashboard. So when you sign up for AnVIL and you look for workspaces, this is what our workspace looks like. So in the workspace, we've included some documentation in terms of how the workspace is organized. One thing that's important is to just look at the overall, how are the data tables organized? We have sequencing data, we have participant information, assemblies, and pangenomes. And so those are in different data tables. In the dashboard section, we have a little bit of documentation in terms of the data itself. So in terms of the production, how it was done in terms of Hi-Fi data, Nanopore, Hi-C. And if you keep going down, you'll see that we have a little bit of documentation as well for the assemblies. And we have some metrics included just so that people can spot check if they're working on an assembly and they see something they don't expect, they can check the QC. And then finally, we have a pangenome section, which is documenting the 3 different styles of pangenomes that have been produced, and then also give information about those methods. Because I should point out at the bottom, we have a more material section. And so, for instance, you can see a link to the GitHub, or one of the GitHubs, I should say. And this one is for the sequencing data production. So you can see some more documentation here, along with read indexes if you're using S3 in order to download the data. This is a good place to go. Okay, so with that, let's show you the actual data. If I navigate to the data tab, you can see that we have a number of different tables here. I think let's start out with a participant table, which shows you the different study samples that are included. And you can see information like cohort, family ID, and sex. And if you go to the sample table, you'll see our nice sequencing data. And so starting from the left, you can see bio-nano, child Illumina, Hi-C, Hi-Fi data, and so on. we go to the assembly table, we can give you a quick example of how you can utilize the data which is housed in this workspace in your own workspace. So here we have 47 assembly samples. And then of these, we have, for instance, maternal FASTA, and then we have those FASTAs aligned to CHM13. So let's download all these rows, and it gives you a TSV file. I have a new workspace here, and you can see this workspace is blank. So this would be a situation where maybe you are hoping to run some analysis and you want to use the HPRC data. For that, I can just go to upload a TSV, drag in the file that I just downloaded. I'm going to import it. And from there, you can see now in this workspace, I have all of the information about those assembly tables. I didn't physically copy over the data from the workspace, so I'm not paying for storage of this data, but what I am holding are the URIs for that information. So I could download it here onto my local. I could use the GS utility to do that, or I could launch a workflow in this workspace. Okay. And with that, I think that's the demonstration of how you